This is the last year for our Barley Max trials. These trials were developed by Mitch Japp from Sask Barley, and they're being led by us through ECRF and Parkland College. The first trial evaluated increasing levels of inputs on an older, poorer performing variety like Metcalfe, and then on superior performing varieties like Synergy and Bow. The increasing inputs involve seeding rate, seed treatment, NPK, plant growth regulator, fungicide at flag, and then fungicide at heading for Fusarium head blight timing.
The trials were conducted at Melfort, Prince Albert, Swift Current, Yorkton, and Scott. The years were 2020 to 2022. Drought was pretty widespread in 21, and drought was also prevalent at Scott and Swift Current in 2022. When analyzing the data, I decided to separate the data into high and low yielding site years. There was a lot of yield variability, and I was curious to see if responses to inputs differed between high and low yielding groups. This is a list of the high yielding site years. You can see the average yields vary from 62 to 105 bushels per acre, and grain protein varied from 10 to 12.4%, which I'm considering all acceptable for malt. Here's the low yielding group. The low yields were the result of drought. Yields range from 17 bushels per acre to 57 bushels per acre, and grain proteins varied from 15% to 17.1%. Low yields caused by drought means high protein, and none of these protein levels would be acceptable for malt. So, on average, the high-yielding group yielded 86 bushels per acre of grain at 11.3% protein, and the low-yielding group only averaged 39 bushels per acre with a grain protein content of 15.7%. Here we have the average yield of the varieties from the high and the low-yielding site groups. Each value is averaged over management level because, while there were no significant interactions between management and variety, in other words, the effect of management was the same for each variety. For both the low and high yielding groups, Synergy was significantly higher yielding than both Metcalfe and Bow. Synergy was almost 9% higher yielding than Metcalfe for both groups. This difference, though, is not as great as what we've seen in the past, where Synergy often is 15% higher yielding than Metcalfe. On each bar I've posted the associated grain protein for that variety. There's no statistics available for the protein numbers because, well, the values are based off of a single treatment sample, which was bulked across the 4 reps. Metcalfe does have higher protein than the other varieties, due to a lower yield mostly, but the difference is not as great as expected for the high-yielding group based on past experience. Let's move on to the effects of management. Here is the effect of management on barley yield, averaged over variety for the high-yielding group. Again, the protein levels are in the little white boxes, and they tend to be lower for management A and D, which receive less nitrogen. All protein levels are easily acceptable for malt, regardless of management, so let's just remove them from the picture. To work out what barley yield was and wasn't responding to, we need to make some specific comparisons. Comparing management B with C shows us there was no response to seed treatment. I'm not surprised, even with the high-yielding group, because conditions were not cold and wet at seeding, which would have been more conducive to seedling-borne disease. A comparison between D and E shows a significant yield increase in response to increasing nitrogen from 90 to 120 kilograms per hectare of soil plus fertilizer N. Again, these rates are including the residual soil nitrogen. If you want to know what these rates are in pounds per acre, just multiply those numbers by 0.9. A comparison between C and E suggests a modest numeric yield increase to Fusarium fungicide, but the difference is not technically statistically significant. Again, the result's not surprising to me, as Fusarium head blight and leaf disease pressure has not been high in recent years. A comparison between E and F shows no yield response to plant growth regulator. Lodging just wasn't a significant issue for any of the site years. A comparison between F and G shows the additional application of fungicide at flag did significantly increase yield. Here's the effect of management on barley yield for the low-yielding site years. Again, the grain protein are in boxes, and you can see the protein is lower for A and D where less nitrogen has been applied. But who cares? All levels of protein are way too high for malt, regardless of management, so let's just remove them. Interpreting the results for the low-yielding site years is a little less straightforward than it was for the high-yielding group. The problem lies in that the yield for Management C was unexpectedly low. When Management B and C are compared, it appears like yield is decreasing in response to seed treatment. It's possible, but I really don't think this is a real effect. Management D has seed treatment too. It also has lower nitrogen but higher yield. Now, it also has fungicide at Fusarium head blight, but I doubt that's contributing to yield during a drought. Now, when C and E are compared, it looks like there's been a response to Fusarium head blight fungicide, which I don't think is likely during the drought experienced at these locations. I just think C is unusually low due to random variation and is causing us some problems here. I do think this negative yield response to plant growth regulator during the extreme drought conditions may be an issue. Anecdotally, I have heard some field scale issues when PGR was applied during the widespread drought of 2021. There really isn't a good reason to shorten your crop during drought. Management G also received plant growth regulator, and it's also significantly lower than Management E. Moving on, there was no yield response to increasing nitrogen detected for the low-yielding group, which makes sense because of the low yield potential. And there was no response to additional fungicide at flag, which also makes sense under dry conditions. Numerically, Management A with the lowest level of all inputs was the second highest yielding treatment. This suggests that there's no positive yield effects from increasing management, and plant growth regulator may have actually been detrimental under the severe drought conditions. Unfortunately, I can't separate out the effect of increasing seeding rate because it is quite possible that having a reduced plant population during drought would have been beneficial. However, if you look at Management B with a higher seeding rate, it too doesn't have a yield that's significantly lower than any of the other management levels. So basically, doing less was more when conditions were hot and dry. So, conclusions. The yield of synergy for the high-yielding group was greater than Bow, and Bow was greater than Metcalf, and for the low-yielding group, synergy was greater than Bow and Metcalf, but Bow and Metcalf didn't differ from each other. Response to inputs was the same for varieties for the high and low-yielding groups. Plant growth regulator reduced lodging and delayed maturity for the high-yielding group, but had no significant effects on yield, as there was very little lodging. In contrast, the plant growth regulator significantly reduced yield and reduced the number of plumps for the low-yielding group. It didn't have any effects on lodging, because there was none, but it did significantly delay maturity still. For the high-yielding group, yield did not respond to seed treatment. For the low-yielding group, it looked like the seed treatment reduced yield. But like I said before, I'm questioning that result. I think Management C was just ridiculously low for some reason, and it could be just random variation. Yield increased for the high-yielding group in response to nitrogen, fungicide, and some combination of increasing seeding rate, phosphorus, or potassium. Yield did not increase in response to increasing inputs for the low-yielding group. The lowest level of inputs was the best economically. Again, I'd like to thank Mitch Japp and Shannon Chant for developing this field study, and also for obtaining funding from the Strategic Field Program.